Imagine you're stranded in the Sahara, parched and desperate for water. But here's the twist: even in the driest desert, you're surrounded by water, hidden in the air as vapor. There's actually 6 times more fresh water floating above us than in all the world's rivers combined. Scientists call these invisible flows sky rivers, a massive, untapped resource. The challenge: how do we get that water down to Earth, especially off-grid? Enter metal organic frameworks, or MOFs. Microscopic, reusable sponges that pull water from even bone-dry air, using only sunlight. Imagine a water panel on your roof, next to your solar panels, generating 10 liters of pure water a day. No electricity needed. Could this be the end of the global water crisis? Today we're building one, testing it, and seeing if we can wring out the clouds. Let's get started. Pulling water from air isn't new. In the Atacama Desert, communities use fog catchers, giant nets that trap droplets from coastal fog, providing hundreds of liters of water daily. It's simple, energy-free, and ingenious, but only works where fog is common. Most arid regions aren't so lucky. Away from the coast, the air holds water as invisible vapor, not droplets. Nets can't catch vapor. The holes are far too big on a molecular level. To solve water scarcity everywhere, we need to go smaller, down to the molecular scale. We need a material that actively attracts and traps individual H2O molecules, even in dry air. This is where chemistry takes over from engineering. Scientists set out to design a molecular Velcro for water, a material so thirsty it could pull moisture from air that feels dry to us. Their search led to a class of materials that seem almost magical. The quest for a universal water solution had begun. It was time to build a trap for the sky's hidden water, and that's where MOFs come in. Let's see how they work. Meet Professor Omar Yaghi, the chemist who pioneered metal organic frameworks, or MOFs, the most porous materials known to science. A sugar cube-sized MOF has enough internal surface area to cover a football field. MOFs are built from metal ions and organic linkers, forming rigid crystalline cages with massive internal space. By tweaking their structure, scientists can make MOFs that specifically attract water molecules. MOF 303, for example, is lined with hydrophilic molecules that love water. At night, it soaks up moisture from even the driest air. In the day, sunlight gently heats the MOF, releasing the water as vapor, which condenses into pure, distilled water. The process is passive. No electricity, no moving parts, just the daily cycle of temperature and sunlight. MOFs can be reused thousands of times without degrading. Professor Yaghi's team has already harvested water in the Mojave Desert with humidity as low as 10%. This is the molecular trap we've been searching for. It's a breakthrough that could change everything. But how do we take this from the lab to real life? Let's look at a company making it happen. Enter Source Global and their hydropanel, a commercial product that looks like a solar panel but generates water instead of electricity. Inside, a super-absorbent material soaks up water vapor from the air, while solar cells power a small fan and provide gentle heat to release the water. The collected water is pure H2O, so each panel adds minerals for taste and health before piping it to your kitchen tap. A 2-panel system can produce 6 to 10 liters of water daily, enough for a family's drinking and cooking needs. It's off-grid, decentralized, and already deployed in over 50 countries, bringing clean water to remote communities and schools. The catch? It's still expensive, but costs are dropping fast. Hydropanels represent a shift from massive, centralized water plants to distributed local water generation. In places where water is scarce or contaminated, these panels are lifesavers. It's a glimpse of a future where water independence is possible for everyone. When water can be pulled from thin air, the military takes notice. For soldiers in arid regions, water is a logistical nightmare, convoys are vulnerable, and casualties are high. DARPA's atmospheric water extraction program aims to create portable devices that generate water on site. reducing the need for dangerous supply lines. They're funding research into advanced MOFs and other materials, plus systems that capture water from diesel generator exhaust. If successful, these innovations could make military units more agile and independent, while saving lives and resources. Prototypes are already being tested. When technology becomes a strategic asset, innovation accelerates. The race to pull water from the air is about more than convenience. It's about security. 9. MOFs are powerful but pricey. MIT's team, led by Professor Evelyn Wang, took a different approach, a cheap hydrogel infused with lithium chloride salt. Salt is hygroscopic, it loves water. The gel soaks up moisture from air as dry as 30% humidity. When heated by the sun, the gel releases pure water vapor, which is then absorbed by a second, salt-free hydrogel layer. At day's end, you simply squeeze the bottom gel to collect fresh water. The materials are cheap, scalable, and efficient. It's a low-tech, high-impact solution, trading precision for simplicity. Multiple paths, same goal, water for all, straight from the sky. 9. These technologies sound like the ultimate water solution, but there's a catch: energy. Desalination, removing salt from seawater, is more energy efficient on a large scale, but only works near the ocean and requires massive infrastructure. Atmospheric water extraction takes more energy per liter, but it's decentralized and works anywhere, no pipelines needed. It's a trade-off: large-scale efficiency versus local flexibility. For now, atmospheric water is best for drinking and cooking, not for irrigating fields. It's ideal for personal use, communities, and disaster relief, where clean water access matters most. The right tool for the right job. Sci-fi fans will recognize this idea from Dune. Fremen survive in the desert with still suits that recycle every drop of moisture. On the International Space Station, astronauts do the same, recycling sweat and urine into pure drinking water. It's a closed-loop system. Total water independence. Now, imagine combining recycling with atmospheric water generators. If these devices become cheap and widespread, they could grant water freedom to homes, communities, even entire regions. No more dependence on rainfall, rivers, or aging pipes. Your water supply would be as reliable as the sun and air. It's a profound shift, mastering the water cycle on a personal scale. 10. If millions of devices pull water from the air, will we stop it from raining? The answer: not even close. The atmosphere holds about 13,000 trillion liters of water, constantly replenished by evaporation. Even if every person on Earth used these devices, we'd extract less than 0.01 1 or 0.01% of daily atmospheric moisture. The global water cycle is too vast for us to make a dent. Locally, the effect is minimal and quickly balanced by wind and air currents. Your water panel won't steal rain from your neighbor. The sky's tap is safe. 8. Some say future wars will be fought over water, but what if we could change that? Atmospheric water tech is like solar panels for water, shifting from centralized control to personal independence. No one can turn off your tap if the tap is the sky. The water is pure, remineralized, and costs are dropping. Would you drink water pulled from the air in your city? Let us know in the comments. Don't forget to condense that subscribe button and ring the notification bell. Thanks for watching. See you next time. 8.